Hello and welcome to my channel. So today let's look at today's daily challenging question 309. Best time to buy and sell stock with cooldown. You are given array prices where price I is the price of a given stock on the ith day, and then find the maximum profit you can achieve. You may complete as many transactions as you like, with the following restrictions. After you sell your stock, you cannot buy stock on the next day. You have to cool down one day. You may not engage multiple transactions, so you must sell the stock before you buy again. So the example one, prices 12302. So the answer is 3 because you can buy on the first day, then sell on the second day, and then cool down one day, and then buy on the fourth day and sell on the fifth day. So it's the maximum profit is 3. So the second example is there's only one price, so the maximum profit is 0. The constraint length is between 1 and 5,000. Price is between 0 and 1,000. So the question is this question is one of the buy and sell stock series. And all those questions in that series can be solved by the dynamic programming. So I'm going to also use the dynamic programmer approach. So let me do some drawing, maybe make this question a little clear about the status. So we can actually assign the three state. So the first one, we can call it like cooled or ready. Cooled, which means you can buy stock. So the initial point is also cooled. So which means you are able to buy stock, and then the cooled can go to the state of hold, which means you bought. You bought the stocks. But actually cooled can continue, can still be cooled. So it can also go to itself, and similarly hold will be, you hold the stock one day and then you can hold it the next day. So actually it can also have a self-pointing. Then after hold, I mean you can also have another state called sold. Sold can only last one day. So it actually from this so you can go from hold to sold, and but sold cannot point to itself because the next day after sold it will be cooled, and then sold will go to the cooled. So this is the plot of the state transition. So we actually, it's quite clear we need to have three states. Yeah, so now let me further write the notes. And so we we can have a DP of like with the 3 dimensions. So we actually need to two-dimensional DP, dynamic programming state, so that we can define 0 as cooled, and 1 as like hold stock, which means we have stock, and 2 as like sold. So we need to return the returning is the dpn minus 1, and the state is either cooled or sold. So the return will be the maximum of this two. And so yeah, output. Yeah, let's maybe start writing the code, and I will explain while I'm writing. So firstly, get the n as a price length, and then define this dp array, and then we can yeah, actually we can start from I equal to 1. So we need to initialize those three state. So dp0 0, which is cooled, which means actually it's 0, so we don't have any profit. dp0 1, the hold. So if we bought on the first day, then we have the stock, but we have actually our profit is negative because we have just spent money. So dp0 2, actually this is like an impossible state, because on the first day we actually cannot sell the stock. So we can use the mean value, int mean value divided by 2 to represent in this state. Also another case is if n is smaller than or equal to 1, then there is impossible to have a transaction, so we can return 0. So that take care of this special case. Then dpi. So now we need to do the transition. So dpi. So one thing is we have only one state, one possibility for the sold. So dpi 2 will so dpi minus 1. It must be holding the stock in the previous state, and then also add the prices of current. So we actually getting back the money of the stock at index I after we sold the stock. So, but the other two has two possibility. One is so dpi 3 is another one, I1. So dpi 1 and I0. Let's work on this two. So we need to have max profit. So we want to get the max of dpi minus 1. This one is so on the previous day, if we are already cooled, then how much profit we get. But also another possibility is in the previous day, we have sold the stock. So it will be this two. And also dpi1 is on the previous day we might also hold the stock. So, but also on the previous day we might be in the cooled. condition. But then we need to minus the price of the current day, so that we actually bought the stock on today. And and we just need to return the max of this dp n minus 1 and 0 dp n minus 1 1. So and the time complexity is on, but the space complexity is also on in this implementation. But it's possible to change it to like convert it to O1 if we want to, because in this implementation we are using a 2D array, but we actually can use only 3 temporary variables. The reason is that the state of the array is only depending on the previous, like dpi is only dependent on dpi minus 1. So it's possible we are using some rolling array to simplify this further to O1 for the space. But it won't change the time complexity. So I'm not going to modify for that, but you can actually look it up if you are interested. But I think in the most interview, if you implement like this, it should be enough. So let's okay. So there's still some error. Let's check. So when the state is 0 cooled, previous one can be cooled. And also, I think to debug this, we can actually print out all the DPs. So let me print out DPI 0. So I is 1 is the so let's look at that 12302. So one I is 1. If it's cooled, the max profit is 0. If it's sold, hold, the max profit is minus 1. If it's sold, the max profit is 1. So in the last one, the max profit is at the state 2 is 3. But why oh, yeah, actually I think I made a mistake. This should be 2. So the state for the output, there can only be two states. One is cold, one is sold. So it shouldn't be hold the stock in the last day, because if you hold the stock, you should sell it and get a maximum profit. Otherwise, your profit is not maximized. Because the price here is actually a positive number. So it should always be, yeah. I think now this should give the correct answer. So let's try it again. Yeah. So that's the reason. Also, I think there is another problem is if we there is a possibility that no matter how we trade the stock, our profit will be negative. So we actually can have another condition that so the minimum profit we get should be zero. Zero means we do nothing. So this is a actually, I'm not sure if we have to add this. Maybe we can do an experiment, see if the first one can pass the AC like an online judge. So yeah, so let's firstly check if this pass all the cases. Oh, it already passed. Okay. Yeah, so that means that this one is not a problem. But earlier, I think when I did in other implementation, it happened that I need to check if it's a negative number. Yeah. So this concludes today's session. If you have a question, please let me know. Thank you for watching.